Okay, let's look at regular polygons today. What we're going to focus on is how to find the perimeter and area of these shapes. Now, we have, or you have learned in the past how to find perimeter and area of all different kinds of shapes, triangles, rectangles, parallelograms, kites, trapezoids, all these different kinds of shapes, but you probably haven't looked at a regular polygon. And remember, a regular polygon means that it is a polygon where all sides and all angles are the same. And so the formula for that is right up here at the top. And let's talk about what some of these variables mean. The capital A at the very beginning is area, and then we're going to take half of the product, so we're going to multiply, and that little a stands for apothem. The apothem is this line right here, starting at the center and going down to bisect that side. And that apothem is also perpendicular, which creates a right triangle inside the figure. And so we're going to use those right triangles to our advantage today to help us find the area and perimeter. The other line that it's pointing to here is called the radius. And the radius is just your hypotenuse in your right triangle. We rarely use radius to find the area of a regular polygon, but sometimes you're given the radius and you'll need it to help you either find the apothem or this outside piece right here. So we're going to look at 4 different regular polygons today, and I've kind of broken it down into chunks so it's easy to remember the steps that it takes to find the area of these polygons. So the first one we have here is a square, and I can say square because I know that all sides are the same if we're working with regular polygons. Now remember back in Unit 7, the very first lesson, 7.1, we found the sum in each interior angle. Well, we need to find this angle right here that I just highlighted in red. And so in order to do that, we go back to that formula where we say 180 times n minus 2 divided by n. So we're going to say 180 times n minus 2, and since it's a square, 4 minus 2 divided by 4. And if I plug that into the calculator, I get 90 degrees. But 90 degrees is the whole thing here that I just highlighted. I don't want the whole thing. I want it where the radius is bisecting that angle. So all I have to do is cut it in half. So every time you find this interior angle, you're going to cut it in half. And that's the angle we're going to work with. And the reason we do that is because now we know that this is a 45-45 triangle, and that's going to help us find those missing sides. So the next question says, is it a special right triangle, or are we going to have to use trig? Well, we know it's 45-45, 90. And so we're going to use that to help us find these missing side links. So go ahead and set up your tic-tac-toe. The given side is 5 square root of 2. It's across from the 90, so that goes here, which makes this a nice easy one because our x is just in front of the radical. So our x's are both 5, which means this is a 5 and this is a 5. And if this piece that I'm highlighting right now is 5, the whole side length would be 10. So our apothem is 5, our side length is 10. So little a stands for apothem, so that would be 5. Perimeter is all the way around. We have 4 sides measuring 10, and so that would be 40, and we're working with centimeters. Area, you could do 2 things. Since it's a square, you could just do 10 squared, 10 times 10, or to practice the area of regular polygon formula, we would say apothem times perimeter divided by 2, so 5 times 40 divided by 2 would give me 100 centimeters squared. You have to find all those missing parts. So that's why I have it split up into all those separate questions so that you remember to find all those missing pieces. So now let's go to the next one. What kind of polygon is this? We have a triangle, and we know it's an equilateral triangle. Okay, for our interior angle, we know that we're going to say 180. It's a triangle, so 3 minus 2 divided by 3. So 180 times 1 divided by 3 gives me 60, But remember, 60 is the whole angle and the radius bisects it. So we have to cut it in half, which gives me 30 degrees. So if I go here to my picture, I know that 30 degrees goes right here. And so the next question is it a special right triangle or trig? Well, we have a 30, so we know that we're going to use 30, 60, 90. And so let's go ahead and set up our tic-tac-toe. Okay, 16 is across from the 90, which does make this easy. So 2 times what gives me 16? 8, so x is your 8. Plug that in and substitute it for the x, 8 square root of 3. So now we just have to figure out where the 8 and 8 square root of 3 go in our triangle. So 8 is across from the 30, so I know my apothem is 8. My bottom side across from the 60 is 8 square root of 3. And if I want to know the whole way across here, I would just double it. So that would give me 16 square root of 3 for a side length. Okay, so our apothem we said was 8. That's that distance from the center down to the midpoint of a side. Perimeter, we know our figure is a triangle, so we're going to say 3 times our side length, which is 16 square root of 3. Our only like terms are the ones that I'm going to highlight here in green, the 3 and the 16. So when we multiply those, we get 48 and stick that square root of 3 at the back. And we're working in inches. Our area, remember, is apothem times perimeter divided by 2. So our apothem times our perimeter, bring that square root of 3 with you, divided by 2. So again, we just concentrate on our like terms, which is multiplying the 8 times the 48, plug that in, divide by 2, and then stick the square root of 3 beside it, and you get 192 square root of 3 inches squared. I don't want you plugging in that square root of 3. I want you to leave it exact. Okay, so that's what you'll do for a triangle. Will it always be a 30, 60, 90? Yes, because that angle will always be 30 degrees right there. Okay, next page. Let's go to our next figure. So our next polygon has 6 sides, so that would be a hexagon. So our interior angle, we would say 180 times 6 minus 2 divided by 6. So 180 times 4 divided by 6 gives me 120. And we need to bisect it because that's what the radius does. So we know that that angle will be 60 degrees right here. 60 degrees tells me that I'm going to be working with a 30, 60, 90 anytime we have a hexagon. So let's go ahead and set up our tic-tac-toe. So x squared root of 3 and 2x. We see that 26 is a side length, but remember we're only working with this little triangle here, so we have to cut that 26 in half to get us our bottom piece. And that 13 is across from the 30, so which makes this nice because now we just plug all of our 13s in. So 13 square root of 3 and 26. We need the apothem here. We don't really need the radius. So the apothem is across from the 60, so we know our apothem is 13 square root of 3. So now we can start solving. Apothem, 13 square root of 3. Perimeter, we have a 6-sided figure with 26 for each side length. Multiply those and we get 156. We're working with millimeters. So remember, area is apothem times perimeter divided by 2. Think about your like terms. 13 times 156 divided by 2, and that gives us 1,014. Stick that square root of 3 at the end, millimeters squared. All right, last one here. We can see it's a 5-sided figure, so we have a pentagon. Interior angle, it's 180 times 5 minus 2 divided by 5. So 180 times 3 divided by 5 is 108. Radius bisects it, so let's cut that in half, giving us 54 degrees. Now, it's not a special, so in this case, we're going to have to go back to our trig with SOHCAHTOA. and labeling with our O's, our A's, and our H's. So let's look at what we were given in this picture. Well, we weren't given the radius, so let's go ahead and draw it. So we have our right triangle. You can do either side. I'm just going to use this one because the 8's not in my way. We know that it's a right angle. So we already have the apothem. We also know that we found this angle to be 54. So if we're here, we can label the 8 as our O. We don't need the radius, so I'm not going to label that. But I do need my A so that I can figure out what the length of each side is in the pentagon. So going back to our trig days, let's refresh. Remember, we're going to use SOHCAHTOA. The S is for sine, C is for cosine, T is for tangent. We labeled O and A, which means we're going to use tangent. So our equation would be tangent 54 degrees equals, and our ratio is O over A. So 8 over A. Well, remember, when our variable's in the denominator, that means we have to divide. So we need to switch places of the tangent 54 and the A. So we're saying A equals 8 divided by the tangent of 54. That's how you're going to plug it into the calculator. 8 divided by the tangent of 54. Make sure it's in degree mode. And when you plug that in, you get 58. No, you get 11. Sorry. Just kidding. Can't read my numbers. 5.812 is what you get for a side length. So that goes here. But again, that's only half. So we have to double it, which means if we times it by 2, we're going to get 11.624. So let's answer the questions. The apothem was given as 8. Perimeter, we have a 5-sided figure times our 11.624, which when we multiply there is the 58. And we're working with inches. Area is apothem times our perimeter divided by 2. You will have decimals here because we are using trig. And so if we plug that in, 8 times 58.12 divided by 2, it gives us 232.48 inches squared. So as you're working through problems, use your notebook, refresh and look back at this because it tells you the interior angle for each shape. That's not going to change. It'll tell you whether you're using specials or trig. That's not going to change based on the shape. If it's a hexagon, it's always going to be a 30, 60, 90. You just have to set up your tic-tac-toe and see what information's given. Or if it's a pentagon, that's the only one we had to use trig with. It's going to be a 54-degree angle. We never want the radius, so you're not ever going to use hypotenuse, which means, well, I say that. If you're given the apothem, it's going to be tangent. You might be given the radius and have to find the apothem. So just based on what you have, remember, refer back to SOHCAHTOA. And these are the same too. If it's a square, it's a 45-45, and if it's a triangle, it's going to be a 30-60. Just find all those parts, the apothem, the perimeter, and then you multiply them and divide by 2.